workshops. We are recording these sessions in case any students who can't join these online sessions. We are recording for that ones, and recording will goes on the Microsoft Teams. If you can't find the recording, you let me know. Currently, ET building is locked. I have waited there up to 11:30. If in case they open the door for us to go inside, but since 11:30 the door was not open, so I thought, okay, we need to run it online, and therefore I have sent you this announcement to make it online. If you have any questions from this workshop next week, from this ones next week we can discuss it. But I think we can just go through it all the details online, so that will not hold you up in a minute. So let me share the screens now. And if you go on your LMS, if you open the LMS, if you go to the week number 2, and that's the workshop that we are talking about today. Now, in these workshops, we have two questions that we basically going to cover. The first one is the authentic case studies project 1 LMS. If you right click on these ones, it will take you through these examples here. Now, what I'm going to do it, I'm going to read line by line. I will show you where these details are on the each, and I will do the calculations, show you the calculations, and show you the step-by-step procedures. And if you have any questions, you can unmute yourself and put it in the chat if you have any questions. So these lessons will demonstrate the process of calculating the loads on the first floor structural beam. So it's basically dead load, live load coming on to the first floor structural beam, indicating the structural plan shown below. Refer sheet as 03 in the full structural engineering set provided below. So what we're going to do it, we're going to go in the structural engineering drawings, and we're also going to refer these questions in the sheet number 3. So let's open these ones. So that's the project that we are talking about. That's the structural engineering for these ones. We don't need to worry about these all details here, but basically this sheet number 3 should be written here as 03 written here, and there should be some beam located on here. That's, I can go back and check it. That's the beam FB1. That's the beam they're talking about, and I will show you this FB1. That's we need to find out what's the load coming on to this FB1. Right. So that's the questions. Dimension of the beam length and spans are measured using the CAD architecture drawing. So if you open the architecture drawings here right now, let me open that architecture drawings as well, and I can show you that architecture drawing, how does it looks as well. In these YouTube video links, as you're going to see it, these are the constructions at this stage. They will gonna put the beam here. The beam has not comes probably in the next steps. I'm going to show you where the beams are. So there is a garage here, and that garage, and there is a first floor and second floor apartments on these ones. I can open the PDF file for architecture drawings to show you as well. So this is the architecture drawings. Architecture drawings does not specify what's the size of the beam and so on. So probably that first I will show you the elevations, then you will get an idea. So that's the apartments that we're talking about. So that's the garage, and then you have this living area, and then you have bedroom. So our beam would be sitting somewhere here on this garage. If you want to show you here, so that's your garage, and then this is the video from the construction. This is a garage, and then you have a story above it. Okay, so that's what the that's what these uh, um, uh, is stuck again. Yeah. Okay. Yeah, because sometimes it going to stuck, but that's okay. So I hope you understand this ones. And the beam in the subject can be visually observed from the 3D view below. So that's what I'm going to do it. I will just going to refer the structural engineering drawings and architecture drawings back and forth. And if we it's working here, okay, sheet number 3. So we're going to have this FB1 on this is the first floor framing plan. So it's like a plan view. If you look at the from the roof, that's what you are seeing. This is your second floor plan, and that's your framing plans. So let's me start my OneNotes, and I will explain you those details in a very great details. Let me put everything on the other sides. I will bring it whenever I need it. So first things we're going to do it is a dead load calculations. Let me put those details here. First things we're gonna do it is a dead load calculations. No, no, no. There's one notes is not behaving. All right. Draw. First ones is dead load calculations. Let's do the dead load calculations. Dead load calculation is a permanent load. The oscillant standards is talking about that is a permanent load. Now, what is the permanent load coming onto this particular beam? So we're going to let me go back to these architecture drawings here, and then let me go back and then we annotate. Here it is. So that's probably the best view. So if you go to this architecture drawing, and you might probably see that this is our let me snip it so we can annotate this one. So our beams are, let me copy, our beam is sitting at here. So our beam is located, let me use the green color so we can see it. So our beams are typically sitting at here. This is a beam here. This is the beam that I'm talking about. That is a beam, steel beam sitting at here. For that particular beams, we need to calculate how much dead load, how much load is coming on. First, we're gonna calculate how much dead load is coming on to the self weight of these ones, and then so on. So there are various layers of the loads coming on to these ones that we're going to calculate on here. Now, if I show you that beam in a minute, so that will also be the part of this ones. All right. So that's the beams that we're going to talk about. Now let me start working towards this one. So dead load from the roof. So we're gonna work from top to bottom. So what we're going to do it? We're going to work from top. First, we're gonna calculate what is in here, and then we go all the way to bottom. So let's work it out top to bottom. There is no rules, by the way. You can work out bottom to top. There is no any issue that we need to always work in the top to bottoms. Okay. All right. So let me get these ones. My standards open as well, because in the standards we're going to see those show those details. Okay. So first of all, let's say there is a roof, right? There is a metal roof, because if you see at your home as well, you can see the metal roof. So this one has a metal roof. So let me put that details here. Number one, the roof has, let's start with roof first. So roof has a metal roof. That is the one load that we're going to get, metal roof. That's the first one. Second, it will have roof truss. I will show you that figure as well. Roof truss, that's roof truss is a second, and the third one is a plaster ceiling board. That's what the total weight of the roof would be look like, right? This is a plaster ceiling board. Now, if I want to get all the details from here, like a roof, you can see this ones. If I magnify, somehow I can going to show you. Let me show you this one. So the roof, that if I magnify, let me magnify through this one on here. Now, if I can magnify, you're going to see this roof. So this any typical roof, it will have a roof truss. As you can see, these are the roof truss. Under the roof truss, there is a plaster board that you're not going to see this roof. So there is a some kind of a plaster board. Above this truss, there is a metal sheet. So I hope you understand that roof has a three components. The first component is a seat. Second component is your truss, and third component is your ceilings. Now let me break it down these all three into the component. So dead load from the roof seats is typically coming from our standards, or some manufacturing supplier also provide that weight. So the roof, probably it will have a 0.06 kilonewton per meter square, right? So that's the weight of every meter square. It will apply this 0.06. So if I just work it out, 0.06, that will give you the 60 newton. So divided by 10, it gives you 6 kilograms, almost 6 kilograms every meter square. And it makes sense. If you cut the seats 1 meter by 1 meters, it will going to give you this 6 kilonewton per meter square. That's the area. Now, this is the link that these are your oscillant supplier. These ones, and if you go and weight calculators and project, I think they have some kind of weighting as well. So if you use one of these product, your uh, I think they would have thickness and all. Yeah. So generally they provide the weight, but generally in our examples, we will provide you those details in these ones. But I generally prefer to use Australian standards. And as I said, if you use Australian standards, there will not be any compromise. So if you go in AS 1170.1, and I'm going to copy that one, the tables, and then I will show you to you as well. So if you go to the ceilings, and there will be roof, walls, and partitions. Do they have a steel corrugated seatings? Okay, that's the one. And if you look at this kind of 0.5 millimeter, including lap and fastening, you can see this 0.05 kilo Pascal. So if you use that once, there is not so much wrong about it. But as I said, this depend on different configuration. Of suppliers also provide that catalog, but I don't want to waste a lot of time on suppliers things. But basically, we can use these galvanized standard calculator sitting 0.05 kilonewton per meter square. That's also given in Australian standards, and we are using 0.06 from the supplier. Now, the next one is your roof truss. Now, again, roof truss is quite challenging, because generally speaking, the roof truss will also be manufactured by the supplier, and we can say that will be 0.3 kilonewton per meter square. That's the roof truss that's going to apply the loads. And this is typical. When you do a lot of practice, you're going to use this 0.3 kilonewton meter square as a load. And plaster ceiling boards, it would be 0.13 kilonewton per meter square. And I will show you where this coming from in our standards. So if you open the standards, 1170.1, and the fiber cement sheets. Let me find out the plasterboard, roofing, fiber cement, and corrugated sheetings. That's fiber cement, aggregate, steel sheets, and ceilings. Yeah, okay, ceilings and gypsum plasterboard. That's the one. That's gypsum plasterboard 0.13. So let me copy these ones. And the ceilings, we will have a zero ceiling plasterboards. So that's your plasterboard's weight, and I can circle it with a red. Gypsum plasterboard, 13 millimeter thick, and that has a 0.13 kilonewton per meter square. So that's 0.13. So if I add up all these values to these ones, I would get the roof total load from the roof. So if I add up all these ones, if I add 0.06 plus 0.3 plus 0.06 plus 0.3 plus 0.13, I would get 0.49 kilonewton per meter square. That's just the load coming from the roof structures. Now we need to calculate this roof load width. As I said, these beams will have to carry the load half this side, half of load coming from this side, and half load coming from this side, right? So it need to carry the load from the both sides, half from this side, half from this side. If you look at the typical garage load width, the roof load width, we can going to measure it in this engineering plans. Let me open it here, and I think I have AutoCAD as well as open, which I can show it to you later. But let me open this one here, the architecture drawing. This one is a structure drawing. Architecture drawings is open in here. Okay, there you go, architecture drawing. So if you use your AutoCAD files and then you use the measure tools, I can open the AutoCAD file later, and then that will going to give you some distance. I'm not sure whether they have written the distance here or not. Probably yes or no. So this is the width. Yeah. This is the floor. So approximately you can see 4 meters on this side, 4 meters on this side. You can see that's what the width of these ones. But if you want to go to exact in the AutoCAD, you can measure that width exactly this one. So if I measure and include all these dimensions, I would just get, because you can see this roof load width is roof load width is almost about 2 meters, as you can see. So that is the 2 meters on this total placer. So that's 2 meters will be accounted for from your roof load width 2.045. All right. So now the questions that I ask you, that you remember that we need to use the both sides of these ones. We need to use both sides. So what happens here? We are using the two beams here. So the neighbor has a second beam sitting on here. So we don't provide the common steel beams between the two properties. If there is apartments here, these apartments will have his own steel beams, and this apartment has his own steel beam. So therefore, in here, we are just taking the half these sides. We are not taking into account other side of these apartments, because there is a beam, specifically steel beam sitting for that particular apartment. So for that case, about 2 meters. So we just take it exact value when I measure from AutoCAD. That roof load width RLW is about 2.045 meters, 2045 millimeters. And you can, rounding it off, you can see clearly on here that it is 4 meters. You can see this is 4 meters, the 4 meters. That's typical. So 2.045. So if I want to calculate the kilo load coming from the dead load coming from the roof, WLR, dead load, W is the load, dead load from the roof. I would say that pressures time perpendicular distance. You know the equations. Pressures time perpendicular distance. Pressure 0.49 kilopascals or kilonewton per meter square, multiplied by this roof load with perpendicular distance meters. You will gonna get this first one is a 1.1 kilonewton per meter that is coming from the roof. All right, I just going to stop here. I talk about 19 minutes. Let me know if you have any questions, or we just breathe and slow down. So we done the roof, that structures the roof are coming on to this ones. Any questions? You can hear me, right?
Yeah, we can hear you.
Yeah, perfect. Thank you for confirming. All right, Scott. Thank you, Nauraj. Thank you, Long. Okay, that's all good. All right. So thank you, Rina. Okay, all going all right so far. So you understand the roof concept, right? The beams and the dead loads coming onto roof. Basically, you calculate the pressures and then perpendicular distance. That is your roof load reach. Basically, half. We did not take the other side of it because there is a two steel beams sitting next to each other that will look after on that side. If there is only single beam, then you need to take into account on the both side, right? All right, now let's talk about the need load from the second floor. So this is from the roof, by the way. Let me is this. Now we done this roof, and this roof basically going to apply 0.49 kilopascals, 0.49 kilopascals, and also about um, 1.1 1.1 kilonewton per meters of load onto these beams. Now let's talk about this second floor. This is here, second floor. So roof is finished. Number two is we're going to do it a second floor. Second floor. Now second floor, same thing like a roof, but there is no any seating. There will be plasterboard here. Then there is a truss here, and there is a plasterboard here. Because if there is a bedrooms, then there this bedrooms has this flooring. We don't have seatings like here, but then you have plasterboards, uh, floorboards or plasterboards, and then you have truss, and then you have ceilings. So we can have first one is your floorboard. Then we have number two as a truss, and number three is a plaster ceiling. So there are three components of your second floor plaster ceiling. And so that's again same thing like a roof, but in the roof we have metal roof. On the top we have roof and then truss and then plaster ceiling. Only one change here is a floorboard. That's what we have. Again, we can use suppliers here. The suppliers will say is going to say that is uh, uh, is a 0.14 kilonewton per meter square. We can also look at the Australian standards to just look at the uh, 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 flooring, roof. Uh, is there a floor, wall, and partitions? Uh, yeah, there would be plus floorboards, roof, floors. Yep. So there will be. They are just talking about the floors that are just made of these kind of tiles and all. They are not talking about the plaster board or fiber cement board. Yeah, but those are somewhere in the ceilings one as well, like 0.12. So this is sittings. And let me go back to this roof. Fiber cement corrugated. I think there was a gypsum plaster board. Yeah, there's around this one plaster board, 0.13 in that range. So let me copy this one so you don't get homeless where these details come from. So the first ones that we want to get this floorboard. So that is 0.13 from AS1170 table A2. So let me go back and put it. So this is floorboard. I use 0.13 because that's what the manufacturing supplier is talking about. If you use 0.13, nothing harms. They still fine. As I said, in this subject is the engineering judgment that you need to use. I can open this kind of supplier that they supply these kind of a flooring board. There are different flooring boards and that they talk about. There will be different thickness, weight. You can see how much kilogram of weight per meter square. You can calculate those weight per meter square and you can find out the actual value. But we're not going to ask you those things in these ones. But as I said, depending on the number of seats and all, it get complicated. Basically, you just use from Australian standards whenever it comes. Don't go on this because you don't have access to these links all the times. If you use 0.13, it's still fine. Okay, for floorboards, which is very close to this one. Um, then we have trusses. I think the truss would be the same truss that we use in the roof because we don't want to change manufacturer. Whatever you use in the roof, they will be same as this one. And again, we will give you these ones in the exams because we don't have access to this one. Then 0.33 kilonewton per meter square for truss. And the plaster ceilings, I think we just use it from Australian standards, 0.13 kilonewton per meter square. And that's what we use in our roof as well. 0.13. So if you added up all these ones, how much kilopascals it's going to provide it? 0.14 plus 0.3 plus 0.13, you get 0.57 kilopascals or 0.57 kilonewton per meter square. A little bit heavier than your roof because roof has these sittings, and that sitting was light metal roof sittings, like a metal roof that was only 6 kilogram per meter square. But here we are using this timber plaster board floorboard that was a little bit heavy. That's what makes trigger these 0.57s compared to 49s. Uh, Floor load width, FLW, floor load width, which is basically again this distance. I can show it to you. This distance from 4 meters. So we just take it. Where was that figure? Here you go. That is basically 4 meters, by the way. Okay, each one is 4 meters. So if you are talking about this roof load width from here to here, we will, if you draw the line in here, and someone might say, what about these 2 meters on this side? No, there is a beam sitting at here. I'm not sure if I magnify, and you may not be able to see. There are two beams sitting. Yeah, there are two different beam sittings. You see, there is a partitions red line, and there are two beam sittings on each side of the unit. So these beams that we are designing it here, they only going to carry the half of these ones. These beams here will gonna carry the half of these ones. They don't need to interfere from the neighbor, right? And that's therefore they are separate. And for that, we will have a 2.045. If you measure it like from this point to this one's in the AutoCAD, otherwise 2 meters still works. Okay, that's not a big difference that in the calculations. Okay, so that's 2 meters that you are using it on here. So floor load width is your 2.045 meters. So finally, dead load coming from the coming from the floor 2 will be your 0.57 pressures multiplied by the perpendicular distance. 0.47 pressure kilopascals or kilonewton per meter square times the perpendicular distance 0.45 meters. We would get the value about 1.17 kilonewton per meters, right? Keep in mind, keep the track of these, all the values. We have how much from roof? We got 1.1 kilonewton per meters. Then we have from the second floor, we got 1.17 kilonewtons per meters. Now we go for the first floors. Let me look at the pictures for the first floors, which is again same things like before. The first floors again has a that's first floor has a, there are two different things. There is a balcony as well. So on the first floors, how do I going to show you the balcony? How do you going to see the balcony? Let me show you the balcony. This is roof. Here it is. You can see there is a balcony in these cross sections. You can see there is a balcony. So in here we have balcony. And if I show you on the video as well, when we open that video, uh, uh, let me get this one in the video, we might be able to look at the balcony. Here it is. Come on. Yeah, because sometimes it just is a 3D video, so YouTube sometimes, yeah, that's it, stop. Okay, you can see here, oops, yeah, you can see here, this is a balcony. This is a garage and then living and so on. So we are designing these steel beams. You can see this, we are designing. There are two steel beams. You can see this one steel beams and there is another one as well. This is for this property, this one is for that property. So we don't need to provide a one steel for both property. Everyone got their own steel beam. So, and as I said, there is a balcony here. That's balcony that's popping it out on these sides. Okay. So that's the balcony that we talk about. Let me complete the story. So now we're going to calculate the first floors. So first floors would be here where it is. We can go to this one's here. The first floor is exactly the same. So you can see there is not much difference. There is a floorboard. There is a trusses. There is a ceiling board. There is a ceiling board. Right. So there is exactly the same as your um, as your first floor. So um, uh, dead load of sorry, dead load of first floor is equal to dead load of first floors. It will be same as your dead load of second floor. Dead load of second floor is equal to this one's value of 1.17 kilonewton per meter. Right? Exactly the same. There is not much difference. Now for balcony area, we need to apply additional 0.46. That is your indoor. That is your indoor for the first floor. Now for balcony, like dead load first floor, for balconies, I think we need to put the additional tiles. That's because you can see we have 0.14, 0.3, 0.13. So let me add up these ones, which is your 0.14 kilopascals plus, that is your floorboard, plus 0.3 trusses, 0.3 trusses, plus you have 0.13 is your floor, is your ceiling board, and then you have additional tiles, like, because in the balcony area, this is your living area and there is a balcony sticking it out. So balcony is sticking it out here, like this is your balcony. Now in the balcony, we don't provide these kind of a plaster boards and all. We provide additional tiles here because otherwise it will gonna go off on this one. So there is additional tiles. So what we're going to talk about, that this one is 0.13 kilopascals. This truss is 0.3 kilopascals. This floorboard is 0.14 kilopascals. You can keep it 0.13. And these tiles, that you are talking about, oops, it's gonna press again. Yeah, leave these lines. Not sure what happens. Then this one is 0.43 kilopascals. Now someone might say, where did 0.43 come from? We will give you, but otherwise you can go to the Australian standards as a reference. And probably there will be the floors, tiles. They might have tiles. There is a paving. There are no tiles. That will talk about zero. Oh, that's the one. That's, we can take it. Perfect. That's the tiles. Let's take it from here. So these ones copy, and that's we going to take it here. We have 0.43 terrazzo paving. So that 0.43 comes from here. So we're gonna add 0.43 kilopascals. So in the balcony area, our pressures would be let's say 0.14 plus 0.3 plus 0.13 plus 0.43 additional 0.43, so 1 kilopascals, and multiply by our floor load with 0.45. You remember 4 meters, right? We just half it, so it would be 2.045 kilonewton per meter. And just make it 5 here, just 2 decimal places. All right, so I hope you understand that one. Indoor area 1.17, balcony area additional 2.05 because of this extra one. Now, finally, then we will just going to finish the dead loads, but there is a one more component that we need to add on. That one more component that we want to add on is your wall, like this wall here. From here to here, there is a wall that will gonna goes on to this till beam. So roof, second floor, first floor, wall, and self-weight. Self-weight we have not considered yet, but we can also consider if you know the size of the beams. Then the last, this one is the third and fourth one. Fourth one is your wall. That goes on because you need a wall between those two units. Now, for this wall that we're going to talk about, that will have, let's say, 0.6. Okay, so the wall that we're gonna create the pressure of 0.6 kilopascals. It would be given to you. Let's say it will be given to you. So if you know the wall 0.6 kilopascals, how much dead load that's going to apply? Let's say W dead load from the wall is equal to 0.6 kilopascals, and in the wall we don't use perpendicular distance, we use height. So if you want to know the height of these ones, probably it's best to go into this architecture's drawing, or let me go back to the architecture drawing. Here you go. This one's, yep. So we need to know the height of the wall. Somewhere they have written something. If you use AutoCAD, it would be easier because you can see here. Let me magnify this one. It would be approximate for me right now. From here to here, 2.7, 2.4, 2.7 plus 2.4 is 5.1, and there is a 300, 300. There will be 450, 450. So about 6 meters height of the walls. And as I said, I can open the AutoCAD for you to reference it, but you can measure exactly the 6 meters. 6.3 meters, considering all these values. Not sure, you can't even take it from here, but in the AutoCADs you can exactly measure it, like 400, 2.7, 400, 2.7, and some roof. So if you add 400 plus 2.7 plus 400 plus 2.4 and some roofing, that will give you the 6.3 wall height. So that would be your 6.3 wall height, 6.3 meters wall height. So the wall that you're gonna apply the things would be 3.75 kilonewton per meter, 3.78 kilonewton per meter. So finally, we can draw up the beams. That's probably in our structural drawing, probably, or somewhere. Let me find out. Do they have these cross sections somewhere? No, they don't have these ones. And then we can go to the structural engineering drawing. Where is the structural engineering drawing? Let me close the windows that are not useful. This one is architecture. This one is not sure if you have structure one. Okay, let's download that one. Structure. Here you go. All right, in the structural engineering drawings, we have these beams. Here it is. I think these ones would be the best view for these ones, or there is anything else. All right, so yep, that's the beams that we have to do the calculations. I'm not sure what's the length of that beam, but we can figure it out for you. the length of that beam is about 5.5 meters. So let me draw up that beam. So what I'm going to draw is your steel beams. Right? And if I draw these ones up, let's say put some kind of supports here, some kind of a supports here, that's your balcony. Balcony is about 2.1 meter, 2.1 meters, and this from here to here 5. But I just measure it by using the by using this ones 5.5 meters, and then you going to have a load. The dead loads coming on to here, and that dead loads that's we going to comes first. Dead loads gonna come from the roof, and how much it is from the roof was 1.1 kilonewtons. From the roof it was from the roof it was 1.1 kilonewton per meter. Then you have um, second floor, and second floor has a 1.17. Second floor has a 1.17 kilonewton per meter. Then first floor has two. One is indoor, 1.17 kilonewton indoor, and another one is outdoor, was because balcony, and that outdoor was 2.05. So that's outdoor is 2.05 kilonewton per meter. And then finally we have wall. Wall is providing 3.78 kilonewton per meter. So if I add them up, so 1.1 plus 1.17 plus 1.17 plus 3.78, you get about 7.2. Let me check my solution so I don't get. So if you add 1.1, 1.17, 1.173, you get 7.22 kilonewton per meter. That's the load that's coming on to beam in the indoor area, 7.22 kilonewton per meter. Now in the balcony, this is a little bit more bigger spikes, and that balcony that will have extra plus 2.05. 1.17, 2.05, and 1.17. So you can have 1.1, 1.17, 2.05, and 3.78, right? So that is your balcony. 1.1 plus 1.17 plus 2.05. So 1.1 plus 1.17 plus 2.05 plus 3.78, you get about 8.1 kilonewton per meters. So in that area, you get 8.1 kilonewton per meters. That's your dead load, right? That is the structures experiencing that dead load. That's what they are talking about. Any questions? Any suggestions? Is it going all right? You need to do it. Look, if you keep watching me, looking at these ones, and then saying, yes, it makes sense, because these calculations can come in a 3 dimension. It can ask you from anything. So you need to experience this by yourself, take a pictures, take a calculations by yourself, and then you experience these ones. Basically, you are getting the pressures, and you are multiplying by the perpendicular length where the loads are going on. So that's what we are talking about. Is it going all right, or any questions? Yes, no, continue or pause. We finish the dead load. Yeah, Naura said that keep going. Maybe other students, we just going to wait. All right, let's keep it going. Now, dead load finished. This one is the end of the dead load. Now we're going to do the live load. Going to do the live load. Live load. Now the live load that we're going to work out. Live load is quite simple than the uh, one that we have on these ones. So let's start with the same philosophy. Let's start with the roof first. Roof. Now live load roof is given in here. In here we go to AS1170.1 and we're going to go here. Here it is, table 3.2. That will be the usefuls for the live load, and that is your table 3.2. So that is your roof, table 3.2. Now that roof that we are talking about, that's the pressures coming onto the roof due to live load. Okay, it's like persons walking on the roof to install the solar panels, or they are walking on the roof to get the some maintenance, air condition, and also live load from the roof that we gonna calculate using this formula, which we're going to use to calculate the area first. And area would be that we're going to do it is your area. This is a plant projection area. Plant projection area, for example, if you have a roof which is 10 degree or 11 degree, and if someone putting the lights on the roof, the shadow that you will get is a plant projection area. You don't need to remember, I think that is written here, that area is a plant projection of the surface area of roof supported by member under analysis in square meters. So that's, do not touch these ones. So the area that's our beams going to expose, that would be your land. Let me go to these ones. This length, which is 2.045 across, so 2.045. You remember that value that we use, multiply by the length of your beam, which is 5.5 meters. That's the length of the whole beam, times by 5.5 meters. And that's your area of the roof, because half of the roof will be taken by these beams and another half will be taken by this another beam. So that will be your 11.25 meters square. And we say that roof live load, roof LL live load is equal to 1.8 over area plus 0.12 is equal to 1.8 over 11.25 meters square plus 0.12. You will get 0.28 kilopascals, which is good because standards does not want to get less than 0.25 kilopascals, which is greater than 0.25 kilopascals. So therefore it is okay. Otherwise, if you get, let's say, answer 0.15, you need to bump up to 0.25. Australian standard do not want to provide the live load less than 0.25. You must have 0.25 and above. Above is fine, but below 25, then you need to make it 0.25. So I hope you understand that one. So if I want to calculate UDL load, W live load from the roof is equal to pressures, which is 0.28 kilopascals, multiplied by the roof load width, which is 2.045. You remember that we use it in the dead load as well. So you get the live load in the UDL of 0.57 kilonewton per meter. Right. Live load from the second floor, we're going to follow the same strategy here, like the one that we follow. One is the roof, then after you're going to get the second floor. So let's go to the second floor now. So there is number 2, second floor for the live load. Now, for the second floor live load, what we're going to do it, we're going to use the Australian standards. Go back here, table number live load is where? Oh, here in table 3.1. And if you look at this table 3.1, domestic and residentials, and then self-contained dwellings, and let's get these tables. So it would be useful. Table 3.1. Copy. And this is a second floor live load. So second floor live load is basically general area, private kitchen, laundry, self-contained dwelling. So that's perfectly fine. 1.5, basically 1.5 people standing in 1 meter square area, each 1 kilograms of weight. So the second floor live load would be your 1.5 kilopascals, right? That's perfectly fine. So the UDL load, that's for the W live load, second floor, floor 2 is equal to your pressures multiplied by the perpendicular distance, multiplied by 2.05, 2.045 meters, you get about 3.07 kilonewton per meter, right? Live load is a little bit simpler than the dead loads, because get the pressures and multiply by floor load width, which is basically perpendicular distance. First floor, you will have again two different, because you have balcony as well. So let's say you have a first floor live load, first floor live load. Now in the indoor, you can see indoor is 1.5, because again this is general area like bedrooms and all and kitchens. So indoor you will gonna get same 1.5 kilopascals multiplied by 2.045 meters. Same like our dead load, right? Remember, dead load was same for the second floor and first floor. So 3.07 kilonewton per meters as indoor. Now for balcony, because you know balcony is a small area and the Australian standards recognize that ones. So less than 1 meter above the ground. So I think in our problems it is above the ground more than 1 meters. If you look at the view, where is it? Here it is. You can see this is more than 1 meter. The balcony is how much? Is about 2.4 meters. You can see here 2.4 meters. So basically, if it's above, if it is less than 1 meters, if someone fell down, no one going to die or injured, right? So Australian standard said is above 1 meters, then you need to boost up, because balcony is a very small area, and Australian standards wants to put stronger materials under the balcony, because if you throw the party at your home, a lot of people in the good weathers wants to get out in the balcony and enjoy the weathers and sunshine or night view or star. A lot of people wants to stand in a small area of the balcony. So the Australian standards saying, oh look, you might have 2-3 people standing, 3 people standing in 1 meter square. So for outdoor, let's boost up some values that they said you need to use 2 kilopascals instead of 1.5 kilopascals, which is quite understandable. I provide you the logic as well. And for that ones, we would have the value would be 4.09 kilonewton per meter. Now, same things that we're gonna draw the figure up for the our beam, that is 5.5 meter longs with the balcony. So this one would be 5.5 meter longs, the whole beams, 5.5 meter long. And if I remember, the balcony was 2.1 meters. You might say, where all these dimension coming from? If you open this AutoCAD file, it will be appearing on that one, 2.1 meters, 2.1 meters. 2.1 meters. Okay, so that's all good. Now you going to calculate this indoor one first, live load. So if I want to calculate the total total live load, I would have from the roof, how much was that? You remember that roof was giving us 0.57 kilonewton per meters. So roof was 0.57 kilonewton per meter. Right. Then after we will have second floor. Second floor is giving me 3.07. second floor is giving me 3.07 live load kilonewton per meters. Then the first floor has a two aspect. One is 3.07 straight away because it's the same people who live on the second floor. They can come down and these will have a same live load because they are same kind of things. But with this outdoor 4.09, that is your party, Christmas party, birthday party, whatever the party you are organizing. This is for party people that you need to make it stronger. And that is first floors, and this is out. This is indoor, outdoor, and I think that's it. Three of them would be okay to work it out. So that will give you 6.71 kilonewton per meters outdoor. This will stay same. There is no balcony here for the second floor, so the live load would be same. So 0.57 kilonewton per meter, and that will gonna give me the little bit of extra for the party people, 7.73 kilonewton per meter. So here you're gonna get 6.71 kilonewton per meter as a live load, and then in the balcony you might have 7.73 kilonewton per meter. Right, so that's your calculations for the live loads. And before I stop, let me calculate the ultimate load. Ultimate load, because you calculate a dead load and live load separately, but we need to combine them. The combinations are given in AS 117 0.0, and I'm going to go in that particular strength requirements. And that's basically gonna go into close 4 point something. Here, close 4.2.2, 1.2 G plus 1.5 Q. Let me get that one and for the strength purpose. And what I'm going to do it, I'm going to put it and underline it. So you know what we're talking about. Let's put it in the red. So we are talking about this ED and this one's combination. So ED, let's use the same ultimate load. ED is equal to 1.2 G. G is your dead load plus 1.5 Q dead load. Basically, they said whatever you have calculated as a dead load, you add 20% on it. Because sometimes you think that you have installed the plaster board, you want to remove the plaster board, you want to put the tiles in the first floor, second floor. So this may happen, right? Renovation and all. So this 20% extra dead load, 50% extra live load. The oscillation standard say that whatever you have done calculations, you done it correctly. There is no any issue. We trust you on your engineering judgment. But whatever you have calculated, let's boost up to the 50% of this one. So how do you work it out these ones? So ED, let's say ED for indoor, EID indoor. So 1.2 and your G dead load. Let's go check. We have figures, I think. This is dead load. All dead load here. So 7.22. So 1.2 times 7.22, right? Plus 1.5 times the live load. Indoor live load was here. I think this is the live load. We had 6.71. So 6.71. All kilopascals. So this is kilopascals. This one's kilopascals, kilonewton per meter square, by the way. So my indoor value would be goes to 18.73 kilopascals. So oscillation standard does not just wants to just add these together, 7.22 plus 6.71. So if I do this 7.22 plus 6.71, I would get 13.93. The oscillation, this is our actual one. Limit state design, it says that 20% extra. So basically, oscillation standards do not want to design for 13.93 kilopascal. That is basically adding simply, but they want to design for 18.73. That is indoor. Outdoor, ED/OD is equal to 1.2 multiplied by outdoor dead load was here, which is your 8.1. Which is your 8.1 kilopascals plus 1.5 multiplied by this outdoor, the party people, the balcony, 7.73. 7.73 kilopascals. So in that case, you get 21.38 kilonewton per meter. Right? So if I draw it up the final figures meaning final beams, this is the beam, this is the here, this is by the way your living area and bedrooms and so on. All this one has a living here and then bedrooms here. You remember that ones? And this one is your balcony. All right, so here your living and bedrooms and all load combinations will give you 18.73 kilonewton per meter. 18.73 kilonewton per meters. And balcony, the party, when you throw the party, then you have 21.38 kilonewton per meter. Yep, so that's your ultimate load calculations. There will be the service load calculations. The service load would be your that is only just goes to the balcony or balcony of the spans, and the service load that we can calculate is the combinations given. Let me go and find the service load. Service load is, by the way, for deflections. This one's for the strength. Once your beam is stable, once your beam is strong enough to not break it, service load is the one that is below the ultimate load. Make sure that this load, service load, look after that you don't get too much deflections. So for that deflection not get too much, we don't need to worry about so much on the service load. So they are little bit relaxed. Probably the combination is here. That's the combinations for the service load. Close 4.3. As for the service load, let me copy these ones. And that's your service load. So that's your service load. So this is dead load. Oh, sorry. This is your dead load. Why is not picking it up? Okay. This is your dead load and multiply by the short-term factors live load, service load. So I will explain you that ones is as well. The factors. The factors here. Here you go. That is your short-term, long-term combination factors. That is perfect. Let's get it done, because there is a symbols that I need to explain you before it goes in the extreme. So in here, we can have a service load, which is the combination of your in the balcony only displacements would be criticals. In this region, your displacements will not be criticals. Okay, I'm talking about displacement load. So this will area would be criticals. So we can calculate the service load in the balcony, which is the dead load G plus these short-term factors multiplied by the live load. So your G for the balcony was, let me go back. The balcony was 8.1 kilonewtons. 8.1 kilonewton per meters. That's your dead load in the balcony, plus short-term factor 0.7. Let's go back to the tables. So in here, they have provided for the floor, residential and domestic, that is your 0.7 short-term factor. So that's 0.7 multiplied by your live load is live load here 7.73. So basically what I'm going to give you the logic as well, 7.73 kilonewton per meter. So basically they say that your service load would be 13.6 kilonewton per meters, right? What does it say is that you don't need to worry about doing your redesign the beam for if it is deflecting too much, you can design for 13.6. So if I draw it up here, this will be, if you calculate the deflections, they will have less deflection here, but then you have more deflection here. So therefore, we are just providing the service load of 13.6 kilonewton per meter. You can calculate the service load here. There is no one harm, but they will not be criticals. Okay, it's the same formula. Now in this 0.7, you see we reduce 30% of your live load. Why? Because these are short-term factors. When you do the constructions in the first day, you will not gonna throw the party. That is a short-term factor. So you will have a party occasionally, right? You will not load your balcony or live load will be going all the times. They will be occasional, so therefore they are just reducing to reduce the 30%. Now, I think I'm talking a lot, or I'm after this workshop. Could you please share the OneDrive with us? Yes, of course, we can share this OneDrive to you. There is no any issue for that one. Yeah, but I'm talking a lot, and let me know if any numbers that's not making sense, or we just pause here because I got a lot of bump bumpy comments saying I go too fast. Look, my intention is not to go fast and overkill all these details. I just want to provide as much as information in your hand. Okay, that's what my intention. My intention is not to rush through any topics, or I don't have any benefit to going and rushing so quickly on any topics. And oh my god, no, I don't. Just stop and pause and ask questions. Would you be able to go through the assignment questions, please? Yeah, Amy, assignment questions. If we have times, we can go through it. I can quickly go through it. But the problem is every Tuesday and Wednesday, Header is offering this assignment consultations. You need to go. I will brief you about this one. There is no any issue, but you need to go on that brief discussions with him. It's like engineers talking with engineers, you know. So I would suggest to book an appointment next week, Tuesday or Wednesday, with your group member, half an hour, and say that, look, we done this one, we done this ones, we done this ones. What do you think? Do you think we missed anything, or do you think we are going in the right directions, or do you? Because he's the one who are the mastermind behind that ones, and he has his selection criteria and his nitty-gritty what he wants to look at, where the student's going to think. So can you do that one as well? So of course I'm going to go through this ones, but that's what his intentions, that he wants the students to have a discussion with him. I think he mentions during the lectures as well. So go with your group, look at this, and see what he thinks, because he's going to go marking as well and all. So we don't want to miss out those any tiny details. All right. Any other bonding questions before we going on to the second examples? For the dead load for the wall, what did you get the height? Okay, how do I get the height? Okay, so if I think basically I need to open the AutoCAD file. Connect. Okay, so I'm going to open the AutoCAD files, and we're going to measure it from there. If you can't see it, okay, let's measure the wall height. Okay. So first of all, I will show you how to download the files. You go here. If you go to the workshops, come on, what happened here? Go to workshops, click on here. Then you said no. Then you go to this CAD architecture drawing, download that one. So if you download this ones, and then it will gonna open it in the AutoCAD. You know AutoCAD, right? I hope you know AutoCAD. First year, semester 1 long ago, but I hope you have still the sharp memory. So you open this AutoCAD, go somewhere here, and you want to measure the wall height. Probably go to measure or linear, and probably pick some points. I think this one is from here. I'm not sure which one point I'm picking, or from here. And then you go here all the way to up, and that will be 6.3. This one's 6.3. Nairobi. Did you get it? Pick the points, bang here, and then go all the way to up, and that is 6.3. How does it sound? For the dead load of the wall, where did you get the height? Okay. Yeah, okay, that's spot on. You can see linear, that's it. And that's AutoCAD file which I open. You have the same access with you as well. any bonding question, any numbers that does not make sense. Look, it cannot go as this simple as this one. If you open this ones by yourself, the files and all, then you might say, oh my god, where these tables all coming from, where this arrow, where these numbers coming from, what's the meaning of these ones, what the first floor, second floor, why there is a indoor and there is balcony, what they're talking about. But after, I'm not saying that this is expert after this one, but listening this 1 hour and 10 minutes of story that you are listening, and now you read, it will be a little bit more ease, I would say, rather than just do it yourself. That's what does it make sense a little bit? I'm not saying that you need to do it yourself, but brothers, sisters, you need to sit down and you need to do it this plus and minus and all these ones multiple times. Otherwise, it will not gonna go. And as I said, this subject is pure engineering. This is this is for real. It's not like someone make up these questions from the waking up from the sleep and said, here is your beam, here nicely loaded beam, here is your length, here is your width, here is your height. Everything is given. If it's not given, add it on, and then you just look at, read it, and plug the number. No, this one is just the real. You see this architecture and these structures that you are seeing, this is for real. I have shown you that one. It's not like a fake one. It's completely real engineering problems that we have solved. And as a structural engineers, you're going to do the same things like the one that I have done. Does it make sense? All right, I just get a water. You also get a water before we start again. All right, so now let me put that 6 meters details as well in the file so you know what we're talking about. Copy and the wall height. There you go. And if I zoom a bit here, then I can get the bottom points. Control V, that's the bottom point, and the top one that we can zoom in as well. And that is the top one. Okay. All right. And any measurements that you think is required, you can go into AutoCAD file, these 5.5 meters and all. they are there. Okay, load width, this one also you can measure it 2.045 meters. But anything that's suspicious, you contact me and then we will be okay. Now, then there is the next ones. If you go to the workshops, there is the next ones, these ones, okay? This also, we're going to go through it. So what we're going to have, these lessons will demonstrate the process of calculating loads on the first floor structural beams indicated in the structural part beams shown below. Refer the sheet as 05. So structural 5 for full structural setup provided below. Same things we can, let me close all other details so we don't get so much confusions. Is there anything open? Let's close this one. Let's close this one. Let's close this ones. Let's close this ones, and we'll leave it this one so on. Okay. So now we don't. So this is a structural engineering drawing. Let me open it. This is basically talking about the slabs that they have. These are the slabs that they trying to work it out. So that's the slab. And that's the whole things that the slabs that we're going to design for your structure. All right, so that's pretty much the questions. So let me read the questions again. So the structural engineering drawings, I done it. Dimension for beam length and span CAD drawings. So you can download these CAD drawings again, and I can open it for these CAD drawings. Yep, that's your CAD drawings for your slabs, and you can take all the measurements. You know how to do the measurements now. I already showed it to you. So that's your CAD drawings. And this PDF files for the CAD drawings as well. That's also on here. That's your CAD drawings. And you can see these full pictures like these, all stories that we have. Okay, so that's all good. Now, what we're going to do it after this one. So basically, I'm going to show you the video as well. This video. So there's a slab that we're talking about. This is a slab that we're talking about. There's a columns, band beams, slab, and I'm going to show you that pictures, the drawing as well. So slab, band beams, and slab. You can see this these slabs, okay? And slab, and as I said, this is just a floor below, the ground floor below. So we're gonna calculate the dead loads and live loads and so on, the same story that we have done before, and we're gonna continue on that one. So let's do that one. So what we're going to do it, we're going to open these structural engineering drawings and we take it from there. Again, same things from top to bottoms that we're going to do it. Right. So what we're going to do it, we're just going to calculate the dead load coming on to these 25 millimeter sections only. So if I go to this structure engineering drawing, or this one is from previous project or what? No, this is the real. And here it is. So let me go through and make a cut on these ones. So what we're going to do it is that we're going to make 25 millimeters of, let me copy these ones. So what we're going to do it, we're just not going to do it. I think that is same thing in your assignment too, that we're going to work on the slab, which is 25 millimeters. So we're going to calculate a dead load and live load on this 25 millimeter slab. This is 25 millimeter slab. So that's That's what we're going to work out, 2500 millimeters of slab. That's what we're going to work out. And if you look at this one in this view, where was the view? If I give you that view as well, not here. Where is the, that's one here. And then you're going to have this view of so it's a bit complicated to look at, but I'm trying to look at that one in a minute. Oh, here it is. So what we're going to do it, we're going to look at this. Let me snip it so you know what I'm going to talk about. So that's the slab you have seen. So that slab is here, and we're going to look at same like 2500. That is the plan view, and that's the elevation. So same 25 millimeters. We're going to look at in that fashions where you have this one which is here, the voids and all. So that's your 25 millimeters. Right. So that's the slab that we want to look at for 25 millimeters. All right, and then another one that we want to get the dimension from is your structural engineering drawing. The structural engineering drawing is here, and then we're gonna take the beam slab cross sections. So that is here, and that slab cross sections that we're gonna take it from here. Okay, let me get this ones. So let's get this one. So that's your slab, and we copy and put it into this ones here. So that's the three figures, and you have seen where I take those figures from. This is a supports here. Let's say here, there is another supports here. There's another supports here, and there is another supports here. So we need to calculate the load coming on to this one. So 25 millimeter sections, and the thickness of these ones would be 280. From here, the someone might say where this coming from. You can use AutoCAD or the scale. So 280, and it's written here 280 millimeters. It's written here 280 millimeters, and in here it would be 450 millimeters. It's a band beam, and I can show you in the video as well. 450 millimeters. So if I go back to that video, so that video is here. So in here, this slab is 280 millimeter, and here this band beam 450, and this is your columns. That's the ones on that plans. I hope it is makes sense. Now let's continue doing that calculations. Now on that calculations, you have, as I said, the thickness and all. I think there are 380 as well. So this will be 380. I can magnify this one's 380. So this cross section is 380. So I hope you understand that one. One is 450, 280, and 380. Okay, and this one is band beam. So this one is your band beam. This one is your band beam. Right, the one that is just a little bit thickening. So we need to have its own weight of the slab and superimpose dead load 1 kilopascals will account flooring weight tiles below service pipe that will be given. So what we're going to do it, we're going to calculate the own weight of the slab. Own weight of the slab, you know the density of the slab 24.6 or 25 we can take, plus we're gonna put 1 kilopascal extra on that one because the slabs will have some kind of a flooring materials like a tiles and all. Someone once said, how about you go and pick this terracotta paving and something like that, right? Because they said I'm not happy that you put 1 kilopascals straight away without any this ones. Why don't you just take 0.13? No, look, these slabs are quite heavy. This 1 kilopascals will be extra material that we're going to look into this ones. All right, so let's start working. First, the own density of the concrete is 24.6 kilonewton per meter cube. I'm going to show you where it is coming from. So if you open 1170.1 and you go in this table A1, page number 19, you're going to get this 24.6. 24 here and 0.6 for the reinforcement. So let's get that one here, 24.6. So I hope you understand this 24.6 story. So basically, we just rounding it off to 25 for easy to calculations. And some students say that why and what, you can continue working on 24.6. When you do a lot of engineering work, you will understand that this is not going to be so much. Your engineers will say that this is not. So the own weight, W own weight of this ones, when it's 28 millimeter thick slabs, 12 millimeter thick slabs, you will have density multiplied by the perpendicular area. 25 meter cube multiplied by the perpendicular area. The area that we are talking about is 280 and 25, so thickness, and this perpendicular area 2.5 meters. You remember we are talking about this area 2.5 and thickness 0.20. So 2.5 meters multiplied by 0.28 meters, which is your thickness. So perpendicular area. You remember that my story? If you have a slab like this, and you watch my videos, there are nice videos, by the way. This is a own loads you want to calculate. Then this is your perpendicular area, like this thickness, and that width. If you want to calculate the loads along these directions, then this is your perpendicular area, and you need to multiply this thickness multiply by whatever this length. So if you are looking for this type, then this multiply by this density times this area. If you are looking for this size, multiply by this area. So I hope it is makes sense. So you have 17.5 kilonewton per meter. Look at that. It's very, very huge. Own weight of the slabs in the 380 thickness, 380 millimeter thickness, same things, same equations, only the change is this 0.28 become point. So 25 kilonewton per meter cube multiplied by 0.20, 2.5, sorry, 2.5 multiplied by 0.38, you will gonna get 23.75 kilonewton per meter. Now, W own weight, you're gonna get for 450 millimeter thickness, and I show you all different thickness, right? You don't get surprised where this number coming from. And this width also I calculated, and this one is 0.45. So that will gonna give you like 28.13 kilonewton per meters. Right. So if I put this all the details on piece of this ones, if I did not write it, so it should be. Can I copy these ones without the numbers, please? So these ones, how to delete this? Go away. Okay. All right. So what we're going to talk about? We have 280 thickness. Then you have 17.5. So the load is up to here 17.5 kilonewton per meters. Own weight of the slab. When your thickness become 450, it will be 28.13. 450, 28.13. So a little bit higher, and that is 28.13 kilonewton per meter. When again this thickness is 280 thickness, then you will gonna get up to here. Oops, this do not go. Then you have 17.5 kilonewton per meter again. Then you will have this tiny bit, which is your 380, 23.75 kilonewton per meter. And then you will gonna get this one's is your 17.5 again, because 280 kilos. It's based on thickness. As the thickness increase, 2.5 is constant. As the thickness increase, that will just going to boost up your dead loads. Now, line load for superimposed dead loads, because there is an extra 1 kilopascals. You remember that I told you the story about 1 kilopascal dead load because of the tiling and all these details. Where did I put the details? That there is an extra 1 kilo. This extra 1 kilopascals that goes on top of these slabs, that because of some kind of an attachments and all tiling and all. So uh, um, dead load for the superimposed dead load SI is a 1 kilopascals times by the perpendicular distance, which is 2.5 meters. So that will gonna give me 2.5 kilonewton per meter. That is your superimposed dead load on top of this own weight of the concrete. So if I just copy these ones here and remove, if I can go, and then I said this one's is constants regardless of the thickness, because this tiling will gonna go up, and that will be 2.5 kilonewton per meter. Right. So far so good. It's clean. And so total dead loads we can just add up: 17.5 plus 2.5, 28.13 plus 2.5, 17.5 plus 2.5, 23.75 plus 2.5, 17.5 plus 2.5. You will gonna get the final dead load that you're gonna get is this. These ones would be a little bit smaller, and we're gonna add up. You're gonna get 20 kilonewton per meter, which is 17.5 plus 2.5. 28.13 plus 2.5, you get 30.63. Is a bit bigger, 30.63 kilonewton per meter. This again back to 280, so it's just gonna go 20 kilonewton per meter. And these tiny bits has these 23.75 plus 2.5, it's gonna get 26.25 kilonewton per meter. And then finally you have these 20 kilonewton per meter. I hope you understand that ones. Now the live load calculations, this is dead loads and live loads. We are not calculating all this roof above and first floor and second floor. You know that story. You can add up these ones. Now for the live loads, what we're going to do it, we have these ones, like if there is anything related to the balcony or and so on, then you will just do this one. So let me go back to the standards. This is a residential, and the live load that we're going to get is this ones from this table 3.1. That is the easy peasy tables, and that is your live load. Now for live load, the story is here. For general area, we can have 1.5 kilopascals, and for balcony area above the ground, 1 meter above the ground, we will have 2 meters. So W live load is equal to, like general area or indoor area, indoor or general area, we will say that 1.5 kilopascals multiplied by the perpendicular distance 2.5 meters, you get about 3.75 kilonewton per meter. That is your general area, kitchen area, and all these private kitchens and self-contained dwelling, bedrooms and all. But if you are just talking about the party people, for the balcony, live load will be a little bit boost up, 2 kilopascals. By the way, party is expensive in every way. Construction expensive, purchasing those party stuff is expensive. So look at this. The cost will start itself from your construction. So 2.5, so that it go 5 kilonewton per meters for the balcony area. Now let me put that details back to here. Oh, sorry, what is opening here? So let me put this one back to here on the live load. This one's here. Now the live load that we're gonna got is constant indoor 3.75. So from here to here, 3.75 kilonewton per meter. That is your indoor area. That is your balcony. This is your balcony stepping down. Now repeat. That is 5 kilonewton per meter, right? And you know why these ones. We have pretty good discussions on that ones. Now, if I want to calculate the ultimate load, how do we gonna do these ones for the ultimate load? We just have a 1.2 G plus 1.5 Q. So ultimate load, you know the story. I can show it to you again. ED is equal to 1.2 G plus 1.5 Q. That is your ultimate load. Where this one's coming from, I can show it to you again. For strength wise, we have here these ones, and then we will have, let's copy these ones and put it here. So this one's close 4.2.2. They're talking about these combinations 1.2 G plus 1.5 Q. So if I just going to do the 1.2 multiply by 1.2 multiply by the date one is 20 plus 1.5 multiply by this 3.75. I would get 1.2 plus times 20 plus 1.5 times 3.75, you get 29.63. So copy the ultimate load that you're gonna get is from here to here is your 29.63 kilonewton per meter, and I show you how to get that. The next one is 1.2 multiplied by dead load is how much? 30.63 plus 1.5 multiplied by this one 3.75. You will get, let me do it, 1.2 multiplied by 30.63 plus 1.5 multiplied by 3.75. You get 42.4 in that area. This one's here, 42.4 kilonewton per meter. Same thing here, 29.63, because same thickness up to here, 29.63 kilonewton per meter. In this zone, little bit where your thickness go 380, and in that ones we have dead load of 26.25. So 1.2 times 26.25 plus 1.5 multiplied by 3.75. So 1.2 multiplied by 26.25 plus 1.5 multiplied by 3.75, 37.13 kilonewton per meter. And in here was 42.4 kilonewton per meter. So this area was 37.13 kilonewton per meter, and this finally this one's is your balcony, which is your 1.2 multiplied by I think 20. We did not have dead load is 20 same. So this is 20 plus 1.5 multiplied by 5. 1.2 times 20 plus 1.5 multiplied by 5, 31.5 kilonewton per meter. So that will be 31.5 kilonewton per meter. Right. So this is all good. All right. So that's all. That's what we plan to do. And I think student asked me to go through the assignment questions, which I can go through it now. And any questions, you put it in the chat while I open the assignments. As I said, these assignments, general advice only. Please do these assignment things with headers. Okay. All right. Now this one's open here. I'm not going to read these instructions. They are self-explanation. An elevation of the portion of the timber post rail paling fence is shown here. Each pale weight 10 newtons. Let me get this on. All right. So what they say that you have this elevation portion timber post and rail railing. So this is your post. This one is your post. The post already said. Okay, post, and this one is post, and this is your rail. Each pale weight 10 newtons. So I think this is pale. So this is 10 newtons, probably 1 kilograms. 10 newtons, 10 newtons, 10 newtons, 1 kilogram each. And 100 by 75 hardwood rail has a unit weight of 12. So this hardwood rail is weight 12 kilonewton per meter cube is a density, right? So that's your rail. If the boat rails are supported to each end by a single M12 bolt, so that is the M12 bolts here, you need to consider the weight of these M12 bolts. Ignore that weight. One rail. Draw a line diagram for one of the rail for the ultimate strength limits under the above loading condition and above line loading. So this one is 2.1 meters. Like this, 2.1 meters. Draw the line. Put this one's here, and then 2.1 meters. If you are a little bit artist and you like to decorate, you can say that this is your rail. Now in rail, first of all, you can calculate the dead load on here, the self weight of the dead load, unit weight of these handrails. So that's 12 kilo. Oh, sorry, what does it cost? So this will have 12 kilonewton per meter cube. You can just get it, the self weight into kilonewton per meter. Multiply by the perpendicular area, and that area is here something. After that, then you calculate the weight of this pail, which is the 10 newtons. So you have 10 newtons weight divided by thousands. So you will get some values here that will be in kilonewtons, right? And how many totals? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever it is, multiply that. That is the total weight. And then I think divided by whatever the space that you have on this one. So that is your dead load own weight, and this railing or the pails weights that goes on here. And then there is no live load. They require live load. Draw a line diagram. This one, I think they somewhere say that live load of 1.2 kilo imposed at the mid span of the rail. Okay, so they say that and another line load diagram considering the ultimate about loading conditions, and then another line diagram considering the additional live load. So that is your dead load, and then ultimate load ED is equal to 1.2 G plus 1.5 Q, and then G is your dead load. Whatever you calculate, this will be 0 at this stage. So that your ultimate load, only dead load. And then there is an additional load. So whatever you calculated in here, whatever you calculated dead load, this ultimate, and you need to put a point load, I believe. That's point load. A point load imposed at mid span. So 2.1 half or whatever is 1.05 at this ones, and then you say that this is 1.5 times 1.2. So that's your live load on that one. So that's the question. But again, just check with Heather what he wants. Book an appointment with him. That's what he's offered to you. I'm just a helping hand. This one here, cross section through an internal wall of the sewage treatment plant is shown. So that is sewage treatment plant. That is wall here. That looks like a water with a 1 meter height and water with 2 meters height. After drawing a line diagram of the loaded wall, so that's the wall and this wall. Determining one, the service pressure P kilopascal at the base of the wall of the tank, so on. So you need to calculate the pressure, I think kilonewton per meter square, you can say density of the waters and all. The design bending moment M star for the strength limited, which 1 meter width of the wall perpendicular to the base. So 1 meters width of the wall, like we done it in this one to resist the design load. So you need to calculate M star like structure analysis. Reference to the authentic structure design project to starter streets. We done it this ones, like your total dead load, live load, that's starter streets they're talking about. These ones, I believe, second one. Where it is. Starter streets. We just done the second examples, I believe. That's the one they're talking about. Is it starter street? Yeah, that's one is a starter street, I believe. Authentic project resources, Bruce's starter street. Yep. Yep, that's the one. The concrete one is a starter street. So that's what they are referencing to. Where is the file? Here. So in reference to the authentic structure project to Sutter Street, we done it. You are required to calculate total loads. I show you total loads, right? I done it for you. This is my assignment question that I done the total loads for you. That is the ultimate load. Live service and ultimate loads. You can calculate the total dead load. Sorry, we calculate total dead load first. Sorry, I misguided you. So the total dead load we calculated somewhere here. Here it is. Total dead load 170, 28, 70. This is your total dead load. Oh, total is here 1 kilopascals. Total here. That's the one before this 20, 30.60, 20. This is your total dead load. The first questions. I already done it for you. So that is the first question, total dead load. Live load. Live load is here. I done it for you. Live load 3.75, 1.5 and all. So that's your live load. Then you have service load. Service load, I done it in the previous example. You can use the same strategy. The service load, we done it here. This is your service load. You refer this one G plus this I as this is your dead load and live load, total dead load, total live, because you already calculated total dead load and live load, right? You calculated total dead load, total live load, and then use the service load equations, which is basically this G plus this. You have total dead load, your total live load. You can take these factors from here, referencing, and then that's pretty much service load. Ultimate loads, we done the ultimate load 1.2 G plus 1.5 Q. So if you come back here in these examples, we done here, this is ultimate load 1.2 G, and I done whatever is 29.63, 42.4, 29.63 and all. That is done it as well. Line is resulting in a first floor concrete slab, resulting from the first floor concrete. So you need to just see the first floors concrete slab, first floor timber framing. Okay, just check the first floor, and I done it first floor for you. I have not done the first floor in these examples, but I done the first floor for you in the another examples. That is in these examples we done first floors and all. You remember second floor. And the first floor was, I done it for you in the another example terms ones. This is wall, and that's your first floor. That's your second floor, and I think I done first floor somewhere. Yeah, second and first floors. I remember that we done balcony and all. First floor. Second floor timber framing, I done the second floor as well. Roof truss, I done it as well with you. If you remember in my first example, consider a segment width of 2.5 meters. I also consider 2.5 when calculating load of first floor slabs. I done the 2.5 meters. The type of load, line and point load must be corrected. Identify in the following diagrams. Refer the Sutter Street project LMS page using the development drawing PDF and guide. I show it to you where it is. Your group should consider the first floor slab, band beam thickness, and framing arrangement as shown in the table below. So I already show you first floors in the another examples. I show you the band beam, where the band beam they're talking about. I think that's the band beam they're talking about is here. And I show you on the video as well. So that is your band beam. This is your band beam because of a different thickness, it will have different loading or whatever it talks about. Band beam thickness, yes. Band beam thickness was, I think I mentioned that thickness before we started even examples. So that was 450 thickness, the same thickness. You can use framing arrangement as shown in the table below. So group number 1, slab thickness 120, band beam thickness is 300. So group 1 need to take 120 here. Band beam thickness is 300. So this thickness, band beam thickness, instead of 450, instead of 280, you take a 300. And then case number 1, yes, so 120 and 300. Group number 2, 130, 310, and so on. So case 1, case 2, case 3, and case 4. So in case number 1, you need to come back here and see the framing above this ones. Like if you second floor and lower floor framing. So if you go in the architecture drawing, it will show you what types of wall, what types of this flooring, there is a voids and all. You can just work it out. Case number 2, you go here, show the architecture drawings, and you work from there. These ones we will talk later. This is not part of this week's. This is a wing loading. Does it help? Or it's you make it worse? Before 2 hours, I was better positions, and now after 2 hours, first you make it face to face to online. By the way, not my fault. University closed the ET building. So that's the things. Otherwise, I was sitting in my office with a nice view. You know, the view from the ET building is nice and fresh. And I'm happy to walk in that next door in ET 219 and roll this same story, what I'm just telling. It's not a benefit for me, by the way, that the university closed these ones, but I still roll my stories online. Yeah, so I hope it helps. What I suggest to be fair, just talk with Heather. He is offering this consulting, and send him an email saying, look, I done the calculations. We have some 15 minutes. Do not just go there and say that open the site. Look, everyone is not that it's not their fault. Everyone don't have that same kind of a teaching style. They will open the these ones and they will circle it for you, and they will say take those measurement. They will click it for you here, and they will just gonna jump it here and say, look at these ones, take these values here, put these in your calculator, do this. These things may not work. You prepare questions and like engineering question. You don't just say that, okay, come on, read the questions for me. I will just sit back and relax, and you just tell me what is happening, and I will put the numbers in. You just do your initial calculations and prepare your questions where you stop and where you want to ask the questions. Familiar yourself with the problems and all. Sit down with your group members, talk with each other. What parts? Let everyone do the same questions and bring the solution to each other. Otherwise, you do these ones, you do dead load, I do live load, you do service load, happy lives, we combine. Good. No, everyone does the dead load, live load, service load. Bring, why you take these ones? My dead load is different than your dead load. How come? What did you use? And then you open, look at this one. I got these ones from here. I got these ones from here. Oh, what did? No, we need to take these ones. You know, that's how the engineering going to work, and that's what the purpose of this assignment. So yeah, but yeah, here 6 more minutes. Any questions? Anything that is puzzling you? Anything that said that, oh, this is not helpful, completely not helpful? After these ones, my brains get worse than this ones. Even I was better positions to calculate dead load and live load. After attending the workshop, it will just get circles. And to be honest with you, I did not understand any single thing that you talk about. Zero. If you this kind of things, we will just run the catch-up session or something to just bring you in the 15 minutes in my office, and we will open the standards. Let's watch this what's in front of me, and which part you did not understand, circle it and do the calculation in front of me. I can offer you this kind of VIP personalized service if you understand zero on that, but I'm sure it is not the case. All right, but as I said, 5 more minutes. Anything that does not help, anything that is not clear, that particular numbers, where it is coming from, let's get that rolling. And by the way, I don't have answer for those assignment questions. Otherwise, and there is no one says this answer questions. Everyone has to work it out. And if I need to know, I need to sit down like you, think like you, and just talk with Heather. Did my solution correct? No one has this calculation at the moment, and there is no software in this ones that they can just put it in. If you try ChatGPT, man, this ChatGPT will gonna make you circle with these ones. So you can try copy paste these ones. There is the image as well. Calculate these things. ES 1170.0. But please review it, okay? I'm not against of ChatGPT. I said it. Just thanks, people. The assignment workshop are more clear now after this workshop. That's good. Thank you, Rina, for the feedback. I hope that is same thing for everyone. Thank you, Amy. Nauraj, any questions? Nauraj, any questions? Nauraj 1, any questions? Nauraj 2, any questions? Oh, no, all good. Okay, then. Thank you very much. I will